Hey there, future coding superstars. Welcome to a journey where your code doesn't just run, it sings. Imagine writing code that not only works, but works beautifully, efficiently, and impressively. That's the magic of code optimization. Ever written code that runs slower than a tortoise in a marathon? It's frustrating, right? You sit there, watching the screen, waiting for something to happen, and it feels like an eternity. We've all been there. That's where code optimization swoops in to save the day. It's like a superhero for your code, making it faster, more efficient, and more reliable. In a nutshell, code optimization is like fine-tuning a race car. Just as a mechanic tweaks the engine to get the best performance, we tweak our code to make it run at its best. We tweak and refine our code to make it faster, more efficient, and a joy to run. This involves looking at every line, every function, and every loop to see where we can make improvements. Optimization isn't just about speed, though. It's about making your code more efficient in every way possible. This means using fewer resources, reducing memory usage, and ensuring that your code is as lean as possible. It's also about making your code leaner and meaner, using fewer resources and taking up less space. This can make a huge difference, especially in large projects or applications with many users. So buckle up and let's dive into the fascinating world of code optimization. Together, we'll explore techniques and strategies to make your code not just functional, but exceptional. Ready to make your code sing? Let's get started. Why bother optimizing your code? Well, imagine waiting an eternity for a web page to load or a game to start. Not fun, right? Optimized code translates to faster loading times, smoother performance, and happier users. That's a win-win for everyone. But speed isn't the only benefit. Optimized code also consumes fewer resources, which is great for battery life on mobile devices and reducing server costs for web applications. Plus, clean optimized code is easier to read, understand, and maintain. A godsend for your future self or anyone else who might work on your code. Now let's explore some common techniques to turbocharge your code. Optimizing your code is crucial for improving performance, reducing resource consumption, and ensuring a smooth user experience. Whether you're working on a small project or a large-scale application, these techniques can make a significant difference. One of the foundational steps in optimization is choosing the right data structures. Choosing the right data structures. Think of data structures like containers for your data. Using the appropriate container for the job can significantly impact performance. For instance, using a set to store unique values is much faster than searching through a list. This is because sets are optimized for fast membership tests, while lists require a linear search. Another example is using a dictionary for key value pairs instead of a list of tuples. Dictionaries provide average O1 time complexity for lookups, making them much more efficient for this purpose. Loop optimization. Loops are the workhorses of your code, but they can also be performance bottlenecks. Minimizing the work done inside a loop or using efficient loop constructs like list comprehensions in Python can make a world of difference. For example, instead of appending items to a list inside a loop, consider using a list comprehension for better performance. Additionally, avoid nested loops whenever possible, as they can exponentially increase the time complexity of your code. If you must use nested loops, look for ways to break out of them early or reduce the number of iterations. Function optimization. Breaking down your code into smaller reusable functions not only improves readability, but also allows you to optimize each function independently. This modular approach makes it easier to identify and address performance issues. For instance, if a particular function is slow, you can focus on optimizing just that function without affecting the rest of your code. Moreover, smaller functions are easier to test and debug, which can lead to more reliable and maintainable code. Caching. Imagine having to recalculate a complex value repeatedly. Talk about a waste of time. Caching lets you store the results of expensive computations and reuse them, saving precious processing power. For example, if you have a function that performs a time-consuming calculation, you can cache the result so that subsequent calls to the function return the cached value instead of recalculating it. There are various caching strategies, such as memoization, which stores the results of function calls, and using in-memory caches like Redis for more complex scenarios. Choosing the right caching strategy depends on your specific use case and the nature of the data you're working with. By implementing these common optimization techniques, you can significantly improve the performance and efficiency of your code. Remember, optimization is an ongoing process, and regularly reviewing and refining your code can lead to better results over time. Python, known for its readability and ease of use, can sometimes be a bit sluggish, but fear not. Here are some Python-specific optimization tips. Asterisk. Embrace list comprehensions. These elegant one-liners can replace bulky loops, making your code more concise and efficient. Use generators for large data. Generators are like lazy iterators that produce values on demand, saving you memory when dealing with massive data sets. Asterisk profile. Your code Python offers excellent profiling tools to identify performance bottlenecks. Use them. They'll show you exactly where your code is spending most of its time. Java energizing your Java code. Java, a stalwart of the programming world, benefits greatly from optimization. It's a language that has stood the test of time, powering countless applications from enterprise solutions to mobile apps. However, to truly harness its power, one must delve into the nuances of performance tuning and optimization. Here's how to energize your Java code. Choose the right collection. Collections are fundamental to Java programming, and selecting the appropriate one can make a significant difference. Java offers a rich set of collections like ArrayList, HashMap, and more. Each collection type has its own strengths and weaknesses. For instance, ArrayList is excellent for fast random access, while HashMap provides efficient key-value pair storage. Picking the right one for your specific needs can drastically improve performance. Understanding the internal workings of these collections can help you make informed decisions, leading to more efficient and maintainable code. Avoid string concatenation in loops. This is a common pitfall that can lead to significant performance issues. Strings are immutable in Java. This means that every time you concatenate a string, a new object is created, which can be costly in terms of memory and processing time. Concatenating them repeatedly in loops creates unnecessary objects. This not only increases memory usage, but also puts additional pressure on the garbage collector. Use String Builder for efficient string manipulation. String Builder is designed for this purpose and can significantly reduce the overhead associated with string concatenation. Additionally, leverage Java streams. Introduced in Java 8, streams offer a functional approach to data manipulation, often leading to more concise and efficient code. Streams allow you to process data in a declarative manner, making your code more readable and maintainable. By incorporating these techniques, you can ensure that your Java code is not only functional, but also highly performant. C++, fine-tuning the Powerhouse. C++, renowned for its performance, can be optimized to squeeze out every ounce of speed. Here are some C++ specific techniques. Pass by reference. Avoid unnecessary copying of data by passing function arguments by reference whenever possible. Use inline functions judiciously. Inlining replaces a function call with the function's actual code, reducing overhead. However, overuse can bloat your code, so use it sparingly. Memory management. C++ gives you fine-grained control over memory allocation. Use it wisely to minimize memory fragmentation and optimize data access patterns. Measuring success. Have you optimized enough? Optimization isn't a one-time task, but rather an iterative process. How do you know if you've optimized enough? That's where benchmarking comes in. Benchmarking involves measuring the performance of your code before and after optimization. This allows you to quantify the gains and see if you're moving in the right direction. Remember, premature optimization can be the root of all evil. Focus on optimizing the critical parts of your code that have the most significant impact on performance. Conclusion. The journey of 1,000 lines begins with a single step. Congratulations! You've embarked on the exciting journey of code optimization. Remember, it's not about memorizing every optimization trick in the book. It's about understanding the principles, choosing the right tools, and constantly striving to write code that's not only functional, but also elegant, efficient, and a joy to work with. So go forth and code with speed, clarity, and a touch of optimization magic. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.